video, we are continuing with vectors. In today's video, particularly, we're going to try to find the volume of a parallelepiped, which is basically, what we learned before, trying to find the volume of a rectangular cube. So, in this example, we are given three vectors, u, v, and w. And I've written down that we have two methods to compute it. So this is the first method, which is basically having the absolute value of v, the vector v cross product with the vector w, then times u. And then the second one is finding the determinant, which is also trying to do cross product, but of all three vectors. In previous video, I did not talk about how to do cross product and dot product, but basically this is cross product and this is dot product, and there's different ways to compute this. So for example, for cross product, let's say we have, usually what we have is we have I, j, and k, which is what we do to represent the vectors. So when we have vectors, right, we have x, y, z. We usually also call that as I, j, and k. And the way we do it is if we have two vectors, let's say v and w, and we want to take the cross product of that, let's just call this a, b, and c. And then a2, b2, and c2. To find the cross product, what we do is for I, we basically match these four together. So we do this times this minus this times this. So b minus c2, b times c2 minus c times b2 minus j times, now it's these ones. So a and c2 multiplied together and c and a2. So a times c2 minus c times a2, and then plus finally k, which is these four. So we have a times b2 minus b times a2. And I know this is really confusing, but once we actually do the example, it'll be much simpler. So there's two methods we can do this. So let's try the first method. When it comes to assigning what v and w and u is, the order really doesn't matter. You can do it like u cross product with w and then multiply by v. The order doesn't matter. The reason why we have cross product is if we think about just solving basic volumes, we usually want to calculate the area of the base and then times the height, right? So remember from previous algebra classes that we've taken, it's always like, for example, length times width times height, for example, when it comes to volume. And so the idea is really the same, except we're just trying to do with vectors. So for this first problem, let's try using the first method. Just to mention also why we use absolute value here is because volumes obviously can't be a negative number, so that's the only reason why. So let's try doing that. So we know v, let's just write it more clear here so we don't have to scroll back up. V is 1, 3, 1. W is -4, 2, and 6. And then, U is 1, 0, and 4. And to use our first method, we want to get the cross product. Again, it doesn't matter, but in this scenario, we're going to try to do cross product of v and w first. So just to write it more clearly, we do v times w, then multiply by u, and then absolute value that. So for this one, v cross w, that is equal to, actually, you know what, let me just write this whole thing out. So first of all, we have the absolute value, and then we want to get the cross product of v and w. And what I like to do when doing cross product is, remember, you have to label them as I, or vector I, j, k, and then write down the values of v and w. So v is 1, 3, 1, 1, 3, 1. W is -4, 2, and 6. And then times U, which is 104 in this case, times, or for now I'll just write it as U, so it's easier. And then to take that, basically again we do the method, so I times 6 times 3, which is 18, and then 18 minus 2, that is 16. Then we do J minus J times 6 times 1 minus 4. So that's basically 6 plus 4, which is 10. And then plus K. 2 times 1 minus 3 times -4. So 2 plus 12, which is 14. And then we multiply by U. So when it comes to this situation, usually we write it as a singular vector. So all this is basically the same as 16, -10, and 14 as our vector. And then we want to multiply by U. So U is 104. Okay. And to compute that, the difference between cross product and dot product is dot product, we're basically just expanding and adding them up. So we do 6 times 1, which is 16. 16 plus -10 times 0, which is just 0. And then plus 14 times 4. And 14 times 4 is just 56. And when we compute that, 56 plus 0 plus 16, that's equal to 72, absolute value, which is just 72. So we have a volume of 72. So there you have, that's our answer. That's the first method. And now let's try the second method. The second method is to find a determinant, which is basically just cross product of all 3 vectors. And this only works when you're given 3 vectors. And in this case, we are given 3 vectors, so we can do that. So what we do is we have 1 vector in the first row, second vector in the second row, third vector in the third row. And again, the order doesn't matter. But let's just say in this case, we honestly can choose anything to be on top. And in this case, let's just go on with U at the top. So let me just copy and paste this formula. Hopefully we can copy everything. Good. So we use this formula to compute the vector, volume. And let me also just copy this so then I don't have to look back up. So, okay, now we have it. We want to find a determinant. Note that this line here is basically the same as like this symbol as I used earlier. It's the same thing. So let's do that. So we have U in the top, so 104. Then we have 1, 3, and 1. And then we have -4, 2, and 6. And we want to find the cross product of all of these. And absolute value that. Sorry, I made a mistake. This should be absolute value and the inner one should be the cross product. Okay, so to find the volume, we apply the same thing. Remember earlier we used IJK, but here instead of IJK we have these numbers, but it's the same thing, so we focus one at a time. So first with 1, we multiply the 3 times 6 minus 2, which is 18 minus 2, which is 16. Then we minus 0 times, well, it doesn't matter what we do in there, but let's just calculate anyway. We have 0 times 6 minus -4, so that's just 10. Oops, 10. And then plus 4 times 2 times 1 minus 3 times negative 4. So that's basically just adding. So 12 plus 2, that's 14. And we have 16 plus 14 times 4, which is 56. Remember to absolute value this, and we get an answer of 7 and 2. And there you have it, that's our volume. Notice that we get the exact same answer. So that is kind of how you approach this problem to find the volume of a parallelepiped with vectors. So thank you for watching. I'll see you guys next time. Bye.